way that all students have shaped this program. Today in our audience, we are joined by all SEP students, HSTAT faculty, and families of our showcase finalists. Over the past few weeks, our current students were all given the opportunity to show off their most proud projects from this year at expos for our entire school. And today we recognize a few projects from each grade that exceedingly impressed the judges in the areas of creativity, usability, practicality, and presentation. What we're going to watch is 9 presentations, 3 from each grade. As you came in, you received 3 index cards. It's 1 for each grade. So at the end of each grade, I'm going to give you some time to pick one of the 3 presentations to reflect on and give the presenter the note card at the very end. So just please wait for all 3 presentations before we go. In the 10th grade, students begin a long journey in the area of web development. They focus on what's called the front end of websites, which is concerned strictly with content and appearance. But students use industry-level tools such as cloud-based collaboration software GitHub, an integrated development environment, as well as Bootstrap to make their websites responsive to any size device, whether it be a phone, tablet, laptop, desktop, and they pick a topic that interests them. And they study existing technologies in that field as well as they dream up future technologies. But making a website is more than a science, it's an art. And so to tell us more about art and animation, let's give it up for our first presenter, Lanlin.
Yo, Vivian, it's you!
So, question, who can draw out of all of you guys? Raise your hands. Okay, who can animate? Who can do both? Alright, either of them. Who can do like none of the above? Okay, alright. So basically, my website is basically about like art and animation technologies. So basically art has been around since like the Stone Age, and animation has been around since like the early 20th century. But it has basically evolved from like drawing by like manually to like more of a digital thing. So here's some sort of like a random screenshot of like what you may see like digitally. This is like from an app. And basically I decided to like incorporate like fuse like art. We have art and we have animation, and also fusing technology together. So this is my website right here. 1 minute. So right here, I have my title, which with clouds, and this is the context, the short context. And I also have like softwares such as Ibis Paint, Procreate, and like also Clip. And I also have like hardwares such as like a graphics tablet and a stylus. I also have like future innovations such as like an app that fuses animation and art together, and a pen, like a stylus that can give you like brushes and like different colors. So here's like the actual like the small model of it right over here. We have buttons, and there's just the screens for the colors and the different brushes. So basically, we have process part 1. It's like more simplified. So basically, I brainstorm my ideas, like researching like current inventions, and I also pretty much like thinking of new inventions, like and formatting the website. And I also like have learned like tools by myself, such as like a tool called A-Frame, which like helps you like create like different models of something. And I also use I created a website using like components, like Bootstrap components, like navbars, and try to like use CSS like title with a background. Yeah, so basically, and I also use like CSS for like customization. And most of my website I use is like make like some sort of like boxes. So this is like one of my code snippets from over here. I use like some sort of container and row, and also like different divs. And part 3 is how I make like my model right over here. I use like A-Frame, which like makes like 3D shapes that makes like different items. One example is like this really long code over here. So like to make like some sort of shape, we have a shape, which is like this example is a cylinder. We choose the position. We have like some sort of height. This is like the radius, also known as how wide it's gonna be. usually like find out a way to like merge like art, animation, and like technology all together. And using like all these other stuff like HTML, CSS, Bootstrap, A-frame, and also pictures, and then maybe turn them into like some sort of website. Thank you.
Thank you, Vivian.
Oh my God,
the theme of art, here to talk to you about photography is our next finalist, Pagan.
Hello, my name is Pagan, and I'm here to talk about photography like Mr. Mueller said. Picture this. What if I told you that everything that you can imagine could be captured, not just a distant memory? You could see it in a real picture, live time. My website helps you dig a little bit deeper into that. Here I use advanced CSS, Bootstrap, and HTML to create something that I was extremely passionate about and very grateful for. This top section over here was a Bootstrap app, one of the most popular components at SEP, using it to highlight specific things on my website. Here, also using Bootstrap, is a timeline of photography, which I'd like to talk a little bit deeper into later on in this presentation. Here, messaging management. Talking about some of the hardware and software of photography. The things that make up a camera are essentially the most important parts, almost. The mode dials, the viewfinders, the flash, the actual body is what makes up the camera. Software is also extremely important in photography. Adobe Lightroom being one of the most popular editing softwares that many photographers use, both new photographers and advanced. Here I use A-frame, a tool that I learned to create a 3D model of a camera, both front and back of a digital camera. This, using Bootstrap, are some of my big ideas, some things I wanted to create. Here, a low light camera, things you can take pictures of in your pitch dark situations. A 3D printer as a camera where you can take pictures and something that you can see could be 3D printed. This one, a femto camera, which is essentially capturing the speed of light. MIT is doing research on this, trying to make this a possibility actually, and they have worked towards this study. Quotes about photography as well here. This timeline section was extremely difficult to do. The challenges I faced were incredible, trying to get the pictures to line up right or find out the information. I've studied a lot, long nights of research about photography. We've been studying the principles of photography since the ancient Greeks and China were around, all the way up until now, where innovations in technology are still coming out every single day with photography, just like how MIT research on it. This was the software and hardware section of photography. Some of the editing softwares that come with it, and also some of the things that make up a camera. There's so many more. There's plenty of types of cameras, from DSLR to mirrorless to film cameras. There's so many different kinds with many different technological advancements within them. This was the code that made up the timeline that I showed, the history. It was easy, but not at the same time. The biggest problem I had was with the imaging, but actually creating the timeline was not that difficult. You would see some of the timeline tags or the divs, some of them being inverted to show that nice little timeline look. This was the section about my ideas. One being, as I can show here, when you click on them, it brings you to a whole different type of view, learning more about them. Information, put little blurbs. So that code shows just how that was made. This section on the left being the initial thing that you see on the website, and the one on the right being the code that was actually within the website. This was the tool that I learned, A-frames. They have many documents online to which I learned, and many YouTube videos I watched. A lot of hours spent on this in class, at home, so much research was done. This was some of the process I had for it. Something simple, like a traffic light or a tree, all allowed me to end up creating the camera to which I made. This was what I started with on the left, of how I wanted the project to look, my website. It changed, not too much, but there was some changes as I made it. I adjusted some of the things, like I was originally gonna have a little blurb on the top about what photography is. Instead, I changed that to the history because I felt like that was extremely important for people to know. And the same thing for the mobile and desktop versions. The purpose of this project was to spread the idea of what photography is and how people don't really understand just how much of an impact it's had on their life. We use it for essentially everything. You see it everywhere. People using their phones, cameras, scientific research, surgeries, criminal investigations. They all use photography in some shape or form. And so spreading the awareness to that and spreading people's knowledge of it was extremely important to me. And that's why I conducted this project. And to conclude, I'd like to give a quote from my father, a photographer as well, and probably my biggest inspiration to do this. Photography, where light alters the heart by holding it still. Thank you.
Right, thank you, Andre. All right, so I can't really rap because my rhymes are hypothetical. But this next website is incredible. It's truly unforgettable. It's about all things medical. Next up, Michaela, Arendac.
Hi guys, so my name is Michaela. I did my project on medicine. So fun fact, you can't tickle yourself. You can try it right now if you want. You can physically do it, but you won't get a reaction out of it. I feel like a lot of people know this, but they don't look deeper into it. So it's because of psychology. When you tickle yourself, you kind of respect it, therefore no reaction is triggered. That was a cause and effect relationship, so like the cause and that was the mental reaction, and then that's the surprise element, and the effect would be the physical reaction, so actually like tickling yourself. There are other reactions like this, so when the sun is out, you may notice that the temperature is warmer, or when you flick the light switch, the light turns on. So essentially, without one, there isn't the other, and that's the relationship that I researched between medicine and technology, where without technology, certain medical achievements are possible. So a few problems I ran into throughout my project, also classified as like cause and effect relationships, which helped me further like understand my topic between medicine and technology. My first problem I ran into was with divs and sections and how to close them off. Here I put in this first section, I had like these cards on my website, which I'll show you later. The first card, I never ended the section, and you can see like the top, the blue highlighted part, that's the starting, but I never ended it, and I just continued on to the next card. That's how it was supposed to be done. What I did was I ended the section, so I wasn't supposed to end the section. Sorry, I wasn't supposed to end the section, and I did. Like, just abruptly finished it. So this is what I wanted. This is what I had. And then I'll show you another thing. So this is my website. A few components I wanted to highlight were like my navbar, which if you click on certain labels, it'll bring you to the designated section. I have a few images also. Here were the cards I was talking about, so you can see that they're side by side. but initially they were on top of each other. On the left, I have existing technologies, medical technologies, and then on the right, I have ideas I brainstormed. Here I put Airframe, another thing I incorporated into my project. It looks a little weird, but I kind of wanted to, I didn't really focus on like physical appeal, I just wanted to focus on like the hardware and the software sections of it. So the blue part, this is an organ scanning technology prototype where the blue part represents the hardware and the green part represents the software. Yeah, and that's like basic overview of the project. So in the first problem, my cause was the placement of divs and how I placed certain elements. And the effect of that was how those elements formatted themselves. My second problem that I ran into was imaging and how the images showed up on my website. So at first I put like the raw link to try to put the image into the project. However, I was supposed to kind of navigate it, so I was supposed to go through the file, like the certain file, for the image to actually show up. So this is what I had at first. I just had the file, the image didn't actually show up, and then I had the actual image. The cause and effect in that was, the cause was my origin, and like the originating file, and then the effect was my actual image. So the primary purpose of my project, again, was to show that relationship between medicine and technology through the context of my process, showing you like the different struggles I went through, and then also my content, so the actual research on my medicine. Content-wise, some of the cause-effect relationships, like one of them was finding medical apps which provided rich medical care, including symptom checks, treatments, listings, all of that. And the effect of that was maintaining health when in absence of a doctor. Another cause in my content was 3D organ printers, and the effect was creating functional organs in replacement of damaged ones at a faster rate. Thank you.
Thank you, Michaela. At this point, you've now seen all 3 10th grade presentations, and so what I want you guys to do is to take some time to pick one of the 3 presentations and write a few glows and a few grows along with your names. So you're going to write your name, write the name of the project, and then at least one glow, something that you liked about their project or their presentation, along with one grow, something they could improve upon, a next step, or maybe... In the 11th grade, students do a deep dive into the language of JavaScript. After learning the fundamentals of text-based programming, they create a project using a third-party library. And a popular choice among 11th graders is a JavaScript tool called Kaboom. And if you like Kung Fu Panda, then you're going to love this next project. Give it up for Bobby Chan.
My name is Bobby, and this is my favorite project. So, growing up, you watch movies and play games, and they make a big part of your childhood. And I'm sure growing up, you recognize this one, or even Mario, or even this guy. And because I enjoyed all of these, I decided to incorporate it within my own game. And this is a sprite, from Kung Fu Panda.
Oh no.
And here are the directions. To win this game, you must complete a task. It is up to you to figure out what it is. Have fun. Use arrow keys to move and space to jump, and some other keys will do different things. he moves around and he jumps, this little thing pops up. It does quite literally nothing. And what it does, I'm just going to tell you the goal of the game because it makes the presentation easier. You have to collect 100 of the dumplings, and throughout the game there are different levels. Don't worry, it's not just this. There are different levels that you go through to collect the dumplings. And now let's talk about how I did it. So to make this project, I used a tool called Kaboom. And what Kaboom is, it is a JavaScript library that makes making games a lot easier. Basically what that means is that it has game-like concepts such as moving characters, adding the characters, and different things like that already coded so that it's easier for you to make the games. So the first thing I did was I grabbed a template. So the image on the left over here is how Kaboom made it. And what I did was I changed the sprites to incorporate the things that I liked. So as you can see the Minecraft blocks, the Minecraft creeper, Kung Fu Panda, the Super Mario little lucky block thing, and the dumplings. Then the next thing I had to do was to change the concepts. In the original game that I took from Kaboom, the way that the player won was by going through the final level. But to make it different, I had to add a conditional. And a conditional is basically, if a condition is met, then something else will happen. For instance, if we had 3-day weekends, then our life would be a lot easier. So over here, you see what happens when the player collides with the coin. And down over here, you can see the conditional, that if the amount of coins collected is equal to 100, then the player will go to the win screen. But I also had to change what would happen if the player went through the final level. So when the player collides with the portal, when it collides with the last one, which is what this is, and I apologize. Once the player goes to the final one, it will go to the lose screen. Then the next thing I did, I forgot to show this, oops. There are small Easter eggs within the game. So basically, if you press the letter P, that happens. Or if you press the letter L, you automatically lose. And there's one last function I'll show later. So I named this function large, and so basically what it is, whenever the player will press on the letter P, then the function large over here will run. And what it does is it changes the scale or the size of the sprite. The same thing over here with the function lost. Whenever the player would press the letter L, then the function lost would play. Throughout this project, I've learned a lot. Not relating to code, but just personally. And a lot of these lessons you hear a lot, but experiencing them firsthand it helped me understand them a little bit more. So the first thing I took away, knowing what you like makes life a lot more enjoyable. The fact that I was incorporating things from my childhood made things a lot easier because I enjoyed what I was making. Acknowledge that it won't be easy. Learning something new isn't the easiest task, and for me, a lot of these steps were not easy because I've never experienced anything regarding JavaScript or Kaboom. Begin somewhere. When I first looked at Kaboom, it was very scary because there were thousands of lines of code that I wasn't sure if I would understand. And the first thing I did was I added Kaboom into my IDE, and then I went from there. Optimize your time. Every opportunity that I was given in class to work on it, I did so. Take things one day at a time. The progress that was used to make this wasn't done in one day, and yes, this project may seem small and simple, but this project was a great reminder that any progress is still progress. And the last thing that I took away is that motivation won't always be there. There are times when I was trying to shrink the sprite or change something that wouldn't work, and I wanted to close the laptop and quit SEP. But I knew that if I could figure it out, then the product would be worth it. So even though I may not have understood every single line of Kaboom, I guess you can still say that I learned Kaboom. Thank you. I will explain this last function thing I did as a joke. If you press letter Y, this YouTube link will pop up.
Oh no. It's a Rickroll. Rickroll. Yeah!
Thank you guys.
Alright, time to edit the footage and not include that.
Rickroll it. Get the Rickroll every time you watch that.
I'm editing that out.
In the spirit of music, you know, I really wanted to make a rap out of the next project. So I went to a rhyming dictionary and I was looking up words that rhyme with the topic. See if you can guess what the topic is based off these words that rhyme with it. Biochemistry, photochemistry, geochemistry, electrochemistry, and stereochemistry. But you'll never figure it out on your own, so I'll just tell you. It's chemistry. Please help me welcome Austin Liu.
Have you ever wondered how much time and effort goes into making a 3D simulation? No! Thanks, Angela. But I can tell you that it's a lot. And that ties in with my project, which just so happens to be a 3D simulation. So, my product is a 3D simulation that displays the atomic model for every single element. It displays the specific shells and subshells for each element, and it supports every chemical element. So this is just a demo. This is the element helium. You can see that these sort of orbiting spheres, there are electrons, and if you choose to look up a larger atom, like say iron, then you can see there's different shells, and you can change the type of information that you wanted to display, like instead if you want the energy level, or you could toggle the labels if you just want to see how the element looks. And this way, it's designed for people who are both familiar and maybe unfamiliar with chemistry. So if you know chemistry, you can use this as like a reference, or if you don't, you can use this as something to learn something new. So I'm going to run through my process. It's kind of a lot, but I promise I won't bore you. So I use two tools for this. 3GS, which is a 3D engine, and Canon.js, which is a physics engine, and these two tools kind of tie in together to create my project. And these are just some words that you might see throughout my presentation. So the first part was, this is a really complex project. So for a complex project, I needed to figure out a way to organize all my code, or else I'm just going to get like lost and lose motivation. So the approach that I took was object-oriented programming. So I created classes that control instances of inferior classes. You can see in these layers, I have different classes that represent the different meshes that you saw in my simulation. And at the top is the app, which is basically like the entire website. So here's a bit of context so you understand why my process. So in a Bohr atomic model, each shell has a certain number of electrons, and the maximum number of electrons in that shell is 2n squared. So for example, here in n equals 2, the maximum is 8. And within shells are subshells. So for example, n equals 3, which is the yellow ring, has 2 subshells, 3s and 3p. So based on this, I made the assumption that for an element's maximum shell, in order to predict the atomic model for it, all I would need was the valence electrons. Because if you saw earlier, both of the shells, n equals 1 and n equals 2, they're completely filled in these examples. But this doesn't always work because here are some examples. So for argon, you can see that shell 1 is completely filled, and so is shell 2. But for scandium, it's not. Shell 3 is not filled. And this is because of the alpha principle, which states that electrons fill lower energy subshells first. So for example, the 4s subshell is lower in energy than the 3d subshell, which is why you see that the d subshell here in shell 3 is not completely filled. So the solution was to use electron configurations, and electron configurations were perfect for this because it gives you all of the information you'll need in order to predict the atomic structure for an element. So for example, from this, you can say that there are 2 electrons and n equals 1, and here there are 8 electrons and n equals 2, and so on. So here's just a basic example of a class. It's sort of like a function, except whatever you pass through it gets stored in the instance of the class itself. So first, I take in the electron configuration as a string, then I turn it into an array and map the subshells to numbers so I can iterate through them later on. And I'm extracting the necessary information from each, I would guess you would say, subshell with rejects. And this is like the algorithm I created in order to create the electron array. So if the subarray for the shell and the subshell exists, then just populate the array with the electron instances based on the electron configuration. Otherwise, just make the subarray first. And the next part was that in order to position these electrons like this, I needed to use some math. So I figured the best way to do this would be to use polar coordinates because the radius, you can see, is a circle, so it's going to be constant for each electron. And then the angle, which I can easily predict using some basic math. So RiceGrades doesn't directly support polar coordinates, so instead, I would need to convert it to Cartesian coordinates, which is the traditional coordinates that you might see in algebra. And this is just the formula that you use to convert polar coordinates to Cartesian coordinates. So now, all I need to do was iterate through this electron array that I just created, and calculate the angle, and then use the radius and the angle to calculate the coordinates. And then I could position it. So the last part was to position the neutrons and the protons. And this was a bit harder because I couldn't use math because, as you can see, they're not as dynamically positioned, and there's no way I was going to manually create the model 118 times. So instead, I would use a physics engine and do it in a relatively small amount of code. So here's a visual representation. First, I'm going to randomly position nucleons, which are protons and neutrons. And here's the origin, which is where I want the neutrons and the protons to end up. And I'm going to apply a force to these protons and neutrons and push them to the origin. And since they collide with each other, they're going to turn into a sort of spherical area. And here's the code that I use for it. So first, I'm setting the position of the body randomly, and then I'm using damping to prevent perpetual motion. And then I'm setting the force of each nucleon to the inverse of this position. And here's why. You see here, let's say the x position of this neutron was negative 100. If you set the force to the inverse, which is 100, it's going to push it towards the origin. And I'm going to do that, for all of the neutrons and the protons. So that's what I did for this. I would iterate through all of my neutrons and protons and apply the inverse force to them. And my conclusion is that there's a lot to 3D programming, more than I originally thought. And throughout the project, I used a variety of project concepts, and many of which I didn't even touch in this entire project. So this is just a small fraction of 3D programming. And refactoring is really important because at first, my project started out relatively simple, but as it became more complex, it became much harder to maintain it and add new things. So refactoring allowed me to understand my code better and made it a lot easier to add more features. And that's all.
Thank you, Austin. Our final 11th grade project will either make you hungry or make you want to do better in school, or both. Let's hear it for Sharivker, Zixuan Yu, and Benjamin Chau.
My name is Samuel.
My name is Benjamin. And my name is Zheng.
And our project is called RiceGrades. It's a grading app. What's the most important food? Rice. How do colleges decide their work? Grades. Put them together and you get rice grades.
For this project, we use Firebase. Firebase is a backend development platform that has many built-in features such as user authentication and a real-time data.
We also use another tool, React, which has a lot of online resources and a component system that organizes our code, as well as high performance for our front end.
So now I'm going to do a brief demo of our project. So as you can see, we have our homepage going, and then we have a little bit of information about us. We got some quotes. For example, I love getting my whole class extra credit just to get 55 on my calculus. Very important quotes. So I'm going to log out, but as you can see, we have our sign-in page, and you can also create an account, and you choose if you're a student or a teacher. So I'm just going to briefly log in as a teacher. Okay, so as you can see, we have 2 classrooms here, but now how do we actually create a new classroom? So we can just click this button, and let's say we want to call it APCSA, which is the best computer science. And then we can put in our grading policy. And now we have to add a student. And now, when I click enter, it all worked. And now we can see we have this brand new classroom. We can edit students. We can add assignments also. It all works perfectly fine, most days.
For the process, we will be looking at the login, and thanks to Firebase, login is a building function, so all we have to do is get the code from the Firebase documentation. And as you can see here, when I'm trying to do the login role, I'm trying to, when the user click on it, we will trigger this function to get the role that we assign to the user. But however, as you can see on this image, it doesn't actually work. So I will give it to Benjamin to talk about the solution.
For the solution, we use HSTAT, which is a React Native tool. It updates the variables so that we can render everything properly. We use HSTAT to update the roles so that when the user switches between the teacher and student, they redirect it to the student and teacher page, which updates the role.
Okay, so now I'm going to talk about how our classroom system works. So the first thing that happens when a teacher loads the page is we loop through our database to see if the email of the teacher for a classroom is the same thing as the currently logged in user, because logically, if the 2 of them are the same, that means that classroom belongs to that teacher. So we run this program, which will do a bunch of rendering. So when actually creating a classroom, the first thing that we have to do is we have to get the user input. So that's what you saw me do earlier when I typed in APCSA, and I put in a student, and then I put in the grading policy. So the next thing we do is we have to see if the students that got added are actually in our database. So that's why we have this get students function. And if the student is not in the database, we remove them from the students array. That way we don't add people that don't exist, and we don't want to prevent any errors later on. And we also notify the user using a message on screen. So now the next thing is we have to actually create an ID for our classroom. The way Firebase works is you have different tables. So for example, we have the classrooms table. And you have to have a unique value afterwards. Otherwise the data is just going to overwrite itself over and over again. And the other benefit of using IDs is we can have classrooms with the same name or different names, and you can change it later on, and everything will work perfectly fine. We also have our payload. A payload is just data that gets sent somewhere. So for us, we're just combining all the information that we just gathered and we're putting it into one JavaScript object. That way we can just send that one piece of code to another function called generate new classroom. And now we just use a built-in Firebase method right here to just create the actual classroom.
A takeaway we had was how to read, because React had a lot of free online documents. We had to skim through them quickly. And we also had too many plans, which lost a lot of time efficiency because we're playing individually rather than collectively.
Another takeaway we have is that coding with two different tools is very difficult. When I am trying to implement Firebase into this project, the process is a little bit different compared to when I first started. And another takeaway we have is problem decomposition, in which whenever a box occurs, we can take hours and hours to try to debug this.
So one of my takeaways has been to not be afraid to take breaks. There have been times where we've been on Discord calls for 4+ hours fixing one minor bug. And when you're working on small stuff like that for so long, it can really get to your head and actually make you less efficient. So don't be afraid if you need to step away for a few minutes and just cool off. And another thing is to not procrastinate your projects. We were going to try to get this done by December, and let's just say that during spring break, there were a lot of sleepless nights, so sorry, Mom. And also, the last thing is, thank you.
Before the next part, I just want to make a quick announcement. Those of you who have third period lunch, you will be able to eat lunch during fourth period, next period. At this point, you have seen all of the 11th grade projects, so like we did with the 10th grade, on your next index card, write your name of the project. And finally, in the 12th grade, students have a choice between two different versions of AP Computer Science. And in both cases, students have ultimate freedom over what they can make. If that sounds stressful, maybe you can relieve your stress by playing some games that were made by our next group. Welcome to the stage, Wilson Lee and Lanlin Yala.
Yeah.
Hi, good morning everybody. Welcome to our presentation, the MiniGame Center. My name is Wilson Lee.
And my name is Lanlin Gao. So here's the demo for our project. First of all, you can see there's 3 different buttons that let you access to different games. And then to start it all, we want to play a game with you guys. It's Pagan. Before playing the game, I would like to ask you guys, what's the first letter people always try to guess when they are playing Pagan? So we'll start with A. Next, I want people to raise your hand and then participate a little.
E. Okay.
No, it's not.
I. You guys are so bad. Doing wrong in a row. What letter? O. C.
our project is about you can access to three-way variety of games, and then the purpose of it is to let users to develop their own entertaining experience. And before showing you all the code and program, we would like to explain you why we want to develop something like this. So as a teenager, we all play games, especially as we believe that classic game is all of our childhood memories. So as we start learning the programming and developing the graphics, etc., we try to figure out how each game works. And then meanwhile, we want to add our own creativity to it.
This is our first game payment. As you can see, it seems a little bit complicated, right? But I want to tell you the concept is very simple. To click through each alphabet and see if it matches against a word, we create a list which incorporates 26 alphabet. Then when as the user presses a letter on the keyboard, it runs through a for loop, checking if the letter matches the word list. If it matches, it will appear on the word list. If not, a payment body will appear.
So here's our lovely tic-tac. So in tic-tac-toe, we all know the winner is the player who first get 3 marks in a row. So how do we do it? The answer is if statement. The if statement lists all the scenarios that can detect whether the winner is winning. So for example, from line 3 to 5, it's our first if statement is if button 1 and button 2 and button 3 are equal to 4, highly simple, the system will detect it and then show it as win.
The next one is the snake game, which the main point is that the level of difficulties increase as the snake touches the red dot and it increases length. As you can see on line 2, the code is about adding the snake pieces to the current position using x and y velocities, which is the coordinate. And as the snake touches the red box. At line 6, the code shows an increase in the score value each time the red box is eaten, and it generates a new location for the red box.
So one challenge we encounter when we create the program is we have a redundant code, which is even though everything is work, but as you can see, we have an argument for each alphabet, which is hard to organize it.
To solve this problem, we use a list to store all the alphabet in a for loop that checks alphabet, which makes the code more organized and easier to read.
So takeaway, when facing a bug, debugging is your best friend.
For debugging, one trick that we use is using the console.log. In the code payment, using console.log, we can see alphabet and its represented index, and when we face any error, we can quickly locate where index is located, and we can see where the error is from.
So thank you all for watching the presentation.
And I would like to give a shout out to our teacher, Ms. Guzman, for being such a wonderful teacher.
Thank you, Wilson and Lanlin. As Regents exams approach, it's time to study. So to help you with that, you might need some flashcards. But not like the index card that you guys are holding. No, this next group went digital. Give it up for Grace Zhu and Vivian Zheng.
Grace, oh no.
Hello, my name is Grace. And my name is Vivian. Find it hard to study for an exam? We have a solution for you. You could use our self-made flashcard website. You can log in. As you can see, you can add as many flashcards as you want. log out function.
This is some of our HTML. On the left side, it shows who will appear if you're logged in, and on the right side, it shows who will appear if you're not.
As for our CSS, these codes were used to make our homepage look presentable.
In our JavaScript, it allows us to fully create flashcards. In the first box of code, when you click on save, it will call add flashcards. You would take what the user input into the question and answer, and after creating, after you can save it with .value, and lastly, you can make the flashcard and clear the user input. On the second box, it will allow you to clear the storage after you delete everything.
For our tool, we use Zheng. Zheng is a Python web framework that allows you to make secure and maintainable websites. Websites that use Zheng are
Instagram, YouTube, Google, and Spotify.
Zheng allows us to create paths that let us go into different HTMLs as long as we can call on them properly. This is shown as by either calling it login or sign up. I can enter either in the login HTML or the sign up HTML. Zheng also allows me to shorten HTML. From what you can see, I'm able to get rid of things like head and body and still have it functional as regular HTML.
For our conclusion, our biggest challenge was Zheng in general because it was confusing and we used Python for it, which we never learned.
Because of this, we had to watch so many different videos and take as much notes as possible. Still, we only gained a bare minimum knowledge about Zheng due to our limited time.
For our takeaway, we learned that communication is key. We worked on this project together and we needed to talk it out.
Also, we learned to understand something, we needed to put in the effort it took to learn anything. And even in those learning, we need a good understanding to be able to put those codes in use. Thank you.
Yo, David, you ready?
You guys ready for the last one?
Yo, King David!
My whole project will make you hungry, both for food and for learning. Be prepared to be amazed. It is with great pleasure that I welcome to the stage Yala, Huang, Chanry, Chen, Hanna, and Vivian.
Good luck!
Ready? My name is Vivian.
My name's Chanry.
My name's Yala. And my name's Hanna. Okay, so before we begin, I'm going to ask you guys what you can make with these ingredients. So we have Parmesan cheese, Italian seasoning, chicken, pasta, pepper, salt, and olive oil. And your choices are empanadas, chicken alfredo, Italian meatball. Just like shout out the answer no. Yay! You're right. So what we made was a cooking recipe, a cooking app called Let Me Cook. And the first part is a software that has all the recipes, as you can see. And the second part is a hardware that includes an autocoder that helps the user chop out the recipes or the ingredients in it.
Okay, so let's start with Swift. Okay, so the tools that we use are Swift and Xcode. Swift is a programming language, and it allows you to code Apple OS apps. And we use Swift, which is kind of like an IDE, so like a code space.
So for our minimal viable product for the app, we made a recipe tab which consists of 5 categories. As you can see, it's meals, snacks, desserts, soups, and drinks. And each category has 2 recipe ideas. The user can click on the recipe and just scroll down and check out the instructions and the ingredients.
Okay, so the first challenge that I faced is like the image sizing. As you can see in the picture on the left, it's like really squished and squashed, right? And I didn't want that, and so I tried using dot scale to fit right here. This is like a modifier, it modifies the images. So I used dot scale to fit, and it brought this thing up, which is not what I wanted. And so I asked my lovely friend Hanna, right? And so I was able to ask her for help, and she taught me about dot scale to fill. And so dot scale to fill allows you to fill in the frame, the whole thing, without having to like squash it or squish it.
As for my challenge, I have this homepage right here and I wanted to add the little tab box, but you don't see it now, but I wanted it to be shown, and currently it isn't showing at the bottom, as you see. So I did a little quick search on Google, and apparently I needed to put a tab bar in my content view page. So now you can see my little tab bar, which is the home.
So for my challenge, I wanted to make the recipes clickable, but as you can see here, I used an HSTAT. That doesn't make it clickable, that just makes the image and the text to be arranged horizontally next to each other. And so I remember I did an own tinkering where I made a list of items to be clickable. And when I went back to it, I realized that I actually had to use navigation link instead of HSTAT to make it clickable. And for our Beyond MVP, we added the option for the user to add their own recipe. So at the bottom and top right, you can see the add icon, and you just add information about the recipe you want to create, the recipe name, category, description, time. And at the moment, the user cannot save the recipe, so that's something we're going to work on in the future.
This is our Beyond MVP challenge. So we created a little data list of the recipes, like ingredients, image, credits, and etc. But because we made this so that we don't have to create an individual page for every recipe, and when we did that, we wanted it to show up, but it didn't show up. And Chanry will talk about how we got to it.
Okay, so we used our good old friend Google, okay? And Google tells us to use dot filter. Dot filter is basically a function that loops through like the data in your collection, and so we have like a data of all like the recipes and everything. So we use dot filter right here. And we were able to loop through, and it allows all of the recipes to pop up on the main menu.
Here are takeaways. Our first one is communication. As we work with multiple people, we struggled a little bit in the beginning to communicate because we all have different time schedules, and what we learned is that because we were working on Smith, we decided that we could all working out individual times, and then by the end of the week, like Sunday, Saturday, we come together to push our information and make sure there's no like merge errors or anything like that. And for time management, it's mainly just like managing our time and efficiently completing the tasks that we have.
Another takeaway is to always look back at your own tinkering, because that's where most of the time you're gonna find the answer to the challenge.
Okay, for our last takeaway, we used Google. We didn't use Google to Google the whole thing. We used it for like little components, little parts. Other than the dot filter, we also used it for like other little things. Okay.
Alright, so the reason why we wanted to work together was the original idea was supposed to have data sent to Superbase, which is like Firebase. It's like a real-time database where it would change the length and slices, and then it would go to the machine, and then once it finishes action, it would return to like 00 as like default, so like it knows that it finishes action and it goes back to the website. But like it required this this chip, which is an ESP32, but like it was really hard to find, and it was mostly for Raspberry Pi, but I was working on getting them, so it was like completed. And then so yeah, so we get to our thing. So here was my minimum viable product. everybody was really confused. There was like only 4 motors and nobody really understood what it does. So my first prototype was this. So basically the motor up here shows the direction, and I had to hand spin it because the motor was too weak. And then the servo motor would cut the food, but however it wasn't really as successful because there's nothing holding up the servo motor over here, so like it will flip. So my second prototype was to reverse it and place the motor on like the wood in order for it to create a slice. So like reverse the motor and the conveyor belt. For my challenges, getting components was really hard. Assembling was also really hard. Wiring and debugging. So for components, these are like all the components I use, and it was really hard to find all these components because first you want to really find any of these in your normal day store, and then finding the specific size for it was really hard. And wire debugging, so like if you do wire, like there's no constant log, there's no signals, so like you had to use this voltmeter in order to detect power from the Arduino to the board, and then if I had any errors, I had to use this voltmeter. So basically, the first thing of all, you have to understand the Arduino board itself in order to understand how I get power, because at first I didn't really care much about the board. I thought all I had to do was connect my USB and then I would just run the code as I put my pins on the breadboard. But however, in order to get power, it requires this 5 voltage regulator. And the reason there was errors because of the polyfuse was, this thing called polyfuse was like heating up, and if anything overheats, you know something's wrong. So at first, when I have errors, I'll test for the 5 voltage regulator over here and see that it only outputs 4.2 voltage, which was already, something's wrong. So I'm testing the right side of my breadboard, and then I see that it only distributes 2.34 voltage, and the left side of the board, and only distribute 1.61. So like there's a huge inconsistency, which there's errors in it, and then the way I had to debug this was taking up the wires one by one and seeing which one is causing the 4.2 voltage. So my takeaway was unexpected words, because this was a very basic concept, but like it was also very hard to build because this was my first time doing hardware, and yeah, building this was really hard. It was also really physically laboring because I had to learn how to use a drill, how to nail stuff in, and I also had to press on the hardest, press on the wires harder, because if I don't press on the wires harder, they sometimes also be faulty, and
Thank you.
We've now seen all 3 12th grade presentations, so as before, again, write your name on the In closing, it is with great honor that we showcase these projects before you today. I hope everyone in this room walks away with the feeling of encouragement by what is possible in the intersection of passion and curiosity and perseverance. Each year we add new students who will be inspired by your great work that has been done so far, and they will have a chance to contribute to it. Our rising students will move on to the next grade and continue to learn both new technologies and new skills that help them communicate, collaborate, problem solve. And finally, we say goodbye for now to our seniors moving on to the next chapter in their journeys, ready to change the world. Will our finalists please come join me on stage? All SEP students, you guys deserve a round of applause.
all setting up. Okay, damn.
All right. For our finalists, we have some gifts. So let's give it up again for Zheng and Lin. Pagan. Michaela Arendac. Chen. Sharivker, Zixuan, and Vivian. And Lanlin. Chau and Vivian. And finally, Yala, Huang, Chanry, Chen, Hanna, and Vivian. All right. As we conclude, in a moment you will be free to stand up and mingle with each other, and I encourage you to meet someone new. You can also use this time to add your note card to the project bag here up on stage. We have our 10th grade here on the left, 11th grade in the middle, and 12th grade on the right. But let me send you off with one of my life mottos, and that is this. Code is cool. Kids are cooler. And kids coding is the coolest. And also, if you're interested in today's slides, here's the QR code. Thank you all for being here and supporting our coding kids. Thank you.